and welcome to the third of three. This is the one where we deal with the tough ones. All right, so here's what we're going to do. We're going to talk about finding the cosine of 11 pi over 16, because that will be fun. The cosine of 11 pi over 16. Well, the cosine of 11 pi over 16 is going to be a positive or a negative 2 plus 2 times the cosine of 11 pi over 8. And I don't know if you've noticed, but every single time I create one of these, I make them too small. Whee! All the way over there, all over 2. Lovely. Now, in order to solve this, we have to know what the cosine of 11 pi over 8 is. And that's why it was important to watch the last video. 11 pi over 8, let's think about. I'm going to write 11 pi over 8 up here so I know what I'm looking for. 11 pi over 8. We've divided pi into 8 parts. So there's 8 of those 8 parts. There's 16 of them. 8, 16. Right between 8 and 16 is 12. So there's 12 pi over 8, which means 11 pi over 8 is over here somewhere. 11 pi over 8 is or the cosine of 11 pi over 8 is a small negative number. So I'm going to go ahead and write this out using this whole positive or negative, and we have a square root of 2. I'm going to say plus 2 times, and here is going to be the structure for the 11 pi over 8 cosine, which we just said is a small negative number. There's this line segment right there. It is a small negative number. Small, so we're taking away negative, so that's happening right there. Now, if you take a look at this 2 is canceling with that 2 and leaving us this structure. We have that the cosine of 11 pi over 16 happens to be equal to there's a 2, there's a 2, there's a 2, and there's a 2. And we've got to figure one other thing out. We've got a minus right there. We've got a plus negative, which is a minus right here. And now we've got to think about 11 pi over 16. Now we have to talk about pi being divided into 16 parts. There's 16 of them, there's 8 of them. 11 is somewhere in between 8 and 16, so we have a negative number. So we have that going on there. Now take a look at the question. 11 pi over 16, 2 times 2 times 2 times 2 is 16. And we happen to have these values that are going in here. Let's try another one. This next one we're going to do, I'm going to erase so we actually have some room for it. And you'll be able to pause and go back. So while I'll be without it entirely, you will still have it. It's my little gift to you. Here we move on. Let's go with what the heck, let's keep the 11, that'll be fun. Let's do 11 pi over, no, let's not do 11 pi over 24. Let's do a hard one. Let's do 7 pi over 24. And you'll see why I think that this is actually harder than 11 pi over 24 in a moment. What we're going to do right now is cut to knowing the answer. We could put 7 pi over 12 into the half angle formula, and effectively that's what we're doing. But we're doing it super fast. We're looking at this and saying, 24, I know 24, that's 3 times 8. And that's 3 times 2, 2, and 2. So I need to have a 2, and a 2, and a 2, and a 3. And I know that 3 is coming last. So got a square root there, and a square root there, and a square root there. This is the structure of the answer. Okay, so if any pi over 24, you're finding the cosine of it, or the sine, you're going to have a 2 and a 2 and a 3 in the top, going in that order. 3 will be the last number, and a 2 in the bottom. What we have to find out now are what are these signs. 7 pi over 24 is in the first quadrant. So the first sign is simple, that's positive. And we think about where this is. See, before, when we were doing, say, pi over 8, we had, I'm just going to look at the first quadrant here to see how many choices we had. We had pi over 8 and 3 pi over 8, and that was it. The number in between 1 and 3, which was 2, 2 pi over 8 was pi over 4, which we already knew. Same thing with the 12s. When we did pi over 12, and 5 pi over 12, the numbers between 1 and 5, 2, 3, and 4, those were all factors of 12. So those were all things that were on the unit circle. But now when we're dealing with something like this 7 pi over 24, let's consider the first quadrant here that we have going on here. All right? Over 24 is a pretty small angle. So we have 1 of them here, and we have 11 here. Now there's some prime numbers between 1 and 11. So we don't have to worry about, because 24 has 3 as a factor, but we do have to worry about 5 and 7. So if we go up this line that cuts this in half, that pi over 4 line, or 6 pi over 24, it's pi over 4, we've got a 5 and we've got a 7 to deal with. So 1, 5, 7, and 11. One's not prime, but those are the numbers, 1, 5, 7, and 11. Those are the numbers that could be numerators for this, where the problem is really a question about a pi over 24. If you're looking for 4 pi over 24, you're looking for pi over 6, and while you're looking for the cosine of pi over 6, you already knew it. So, anyway, we're talking about this value right here. So we're talking about one of the middle values. So we have a very big one, we have a somewhat big, a somewhat small, and a very small. So we're looking for this one right here. We're looking for this cosine right here. We are looking for the somewhat small value. Somewhat small is going to happen by subtracting a little rather than subtracting a lot. Very small will be subtract a lot. So we are going to subtract a little. This makes a small amount that we subtract. And that, I guarantee you put into a calculator and you find out what is that value right there. And then you ask your calculator in radian mode, what is the cosine of 7 pi over 24? Which, by the way, yeah, that's a number. So it's about a radian. I mean, that's about where that is. This number can be really close to whatever that value is. It's close to 1/2. So that's it. That's a way to use the half angle formula. Super duper fast. And therefore you can find anything if you just know where you are. Thanks for watching all these videos. You've been awesome. I've been awesome. Everything's awesome. Have fun doing the homework. I'm going to go ahead and sign out.